and welcome back to the second talk. So, Professor V. Kamakoti is our next speaker. He is currently the professor in the Department of Computer Science and Engineering and Associate Dean of the Industrial Consultancy and Sponsored Research at IIT Madras. He also serves as the Director in charge of the Technical Operations of City Union Bank. Professor Kamakoti is a member of the NSAB National Security Council. He served as chairman of the AI Task Force for Ministry of Commerce and Industries. He is the PI for Shakti, Rise Lab, Disha, and so on. Professor Kamakoti and his team have been leading the efforts of design and development of indigenous India-specific family of microcontrollers based on RISC-V open instruction set architecture. Professor Kamakoti has been awarded the Abdul Kalam Technology Innovation National Fellowship in 2020, IESA Techno Visionary Award in 2018, IBM Faculty Award in 2016, DRDO Academy Excellence Award in 2013 by Honorable Prime Minister Shri Narendra Modi, and in 2007 was awarded the Young Faculty Recognition Award by IIT Madras. So we're glad to have you, Professor. Over to you.
Thank you very much. Are my screen visible?
Yes.
Yes. Okay. Thank you. Thank you for this wonderful opportunity. In the next 20 minutes, I'll very quickly go through an experience that we had in building a very large-scale data-driven system. I'll specifically take the case study of Aarogya Setu, which is currently being used by more than 15 crore users across the country. And the number of users are growing on a day-to-day basis. As we see, a picture talks millions words. Similarly, a data can give us million insights. But the caveat here is that the picture, when properly drawn, will speak million words. And similarly, a data, when properly sensed and analyzed, will give us million insights. And that has been the real challenge in bringing up a system like Aarogya Setu to basically go and look at many things about COVID, lot of uncertainties about COVID, handling them and coming out with something actionable and effective too. And I would like to share that experience within the next 15 to 20 minutes. When you look at engineering a very large scale system, there are three components to these type of data-driven systems. One is the edge sensor, a mechanism by which we sense the data. And then there is an intermediary level, which basically does certain accumulation, aggregation, encoding, encryption, etc. And this part of the data, after some amount of massaging and processing, goes to a cloud server, and where a cloud analytics is done, where some of the decisions and actionable items can be taken up. So there are three essential components: the edge sensor, the intermediate level, and the cloud analytics, which essentially form the basis or the framework for engineering a large-scale data-driven system. Now, when we look at this project, it's been extremely interdisciplinary in nature. We need computer scientists who can develop software, who can develop portable software, because this is going to be on a mobile, and we have varieties of mobile with varieties of operating systems. Then we need, of course, ML. We need networking specialists. We need people who can write device drivers, who can actually write, kernel architects, who can build up systems. And on the cloud, we need people who have database experts, who are visualization experts, who can develop dashboards, etc. This is one part from the computing angle, but then there is an epidemiological angle also. Then we need statisticians. We need people from the humanities to understand behavioral studies, and then we need legal people. So at least, I may have missed some in this, but at least 5 different disciplines have to work together to make a successful data-driven system. And that is what Aarogya Setu is all about. When we look at the development cycle, there is a software requirement specification, and it is specific to different projects. Then there's a great amount of functional testing that needs to go, because this is something that is directly related to the health and the well-being of an individual. And there is a great need of certain specific correct inputs that needs to be sensed a wrong decision can really cost serious consequences, result in serious consequences if not handled properly. And then there is a need for performance testing because it's going to be used globally within India and in large numbers. Security becomes extremely important because this carries an amount of personalized data, and so we need to look at the privacy and the security in great detail. And then there is the deployment that happens. And then most importantly, once you deploy the system, it is like building a dam. We fill it with water only when end user accept it and they start using that and give us proper inputs. So the end user acceptance is extremely crucial for the success of such systems. And then after we get these data, then there is after we need to study the usage of this data and also get some inference by which we can take certain actionable items, we can derive certain actionable items and take some actions based on them. And all these things are very important in building up large-scale data-driven systems. And I will basically explain very quickly on each of these points with using Aarogya Setu as a case study. So when we start building the software requirement specification, these systems need, specifically when we look at these, what we call as the cyber physical systems, we need one intuition which is going to be the most important. See, COVID, of all uncertainties we have, right? What medicine to use, how does it spread, when does it come, when does it go, will it stay there, will it give antibody? Nothing is known very clearly. And every day we get a different type of treatment, different type of articles, different type of news items on this. But one thing certain about that is certain to spread through contact, and this contact is measured as a function of proximity and the time two people spend together, right? And so this forms the basic intuition. And today, if you look at a common denominator across multiple mobile phones today, mobile becomes a very important entity in this development of the system. And the mobile is the actual interface on the edge side where we start sensing data. One thing common across these mobile sets would be the Bluetooth interface. So Bluetooth has been taken as a sensing mechanism because it is commonly available across mobile sets, and there is a standard. It is governed by the exchange of data is based on a standard. So the entire working, many of you might know, but I'll just explain it very shortly. Two users, A and B, both of them have installed Aarogya Setu, and they keep the Bluetooth on. And what we do is when they install Aarogya Setu, we give them an unique ID, and that is known only to them and not to anybody else. This is basically to maintain the privacy and secrecy of a mobile number. And if A comes in close proximity to B, or any proximity to B, the distance is recorded based on the Bluetooth strength, and the time of contact, how much time they were together, are recorded along with the location information. And A's detail, the DID of the A, not the mobile number, the DID of the A, along with the recording of the distance and the time duration on which they were being in close contact, this is stored in B, and similarly vice versa in A. But A will not know B, and same for B. B will not know A. The common link is only this unique ID, which is known only to the person and to a very secure server in the cloud, right? And so if in the event of one of them turning positive, then the information is basically given to B that you have come in close. For example, A becomes positive, then B is informed that you have come in close contact with some person, not really the identity of A is not revealed, but some person, and you need to go and do certain actions depending upon the proximity to which you are there with the other person and the time you have spent with the other person. So this is about the edge. Now comes the intermediary level and the cloud level. And when we start developing this, the first thing that came up is privacy. So the entire system has been based on privacy first. And then the next comes is the security, where there is because we have access to personal data, and that is very important that this is extremely protected. And so security was most important, one of the most important thing in the whole agenda. And also we had to keep track of certain things, like creating chaos. If people can use this to create chaos by spreading some false fake information. So we had all these things in mind. And when I'm going to quickly explain you how what were the design considerations when we looked at the intermediary level and the cloud level, I will quickly touch upon some of these issues. The intermediary here is the mobile phone. The app has to be downloaded through the app stores like Google Play Store or the iOS, and it is also available on feature phones like Jio has. This has been ported for the Jio. And what will the intermediary do? It will sense data in some encrypted form, and it will also interface with the cloud. The data that is sensed about people who are coming in proximity is stored in an encrypted form within the database, within the mobile number. And in every 15 days, the data that is more than 15 days old is erased automatically. So there is a sunset clause for the data that is stored on the mobile. First, it is stored in an encrypted form, and second, it is erased after 15 days. The reason for 15 days is that many reports today say with great certainty that the spread of COVID will be within the 15 days. And the intermediary level also allows a user who has subscribed to Aarogya Setu to do a self-assessment with symptoms, like whether they have a cough, fever, loss of taste, smell, or difficulty in breathing. This can be basically told at this date, this time, I am here. The location detail is also given, and I have these problems. Now, at the cloud level, the self-assessment that is done by the different users are uploaded in a confidential manner. And for all positive tested patients, where we get this data from a database from ICMR, when they are confirmed as positive, we go and make the mobile number positive. So this is done by a centralized system, and it is not done by the user. For example, if I turn positive, I'm not the person who will make it positive, but a centralized system will make it positive. And the reason for this is quite simple. That's one of the things is that if I really want to create a chaos and I want to create a social disturbance, I can actually go to a mall or some crowded place, and a lot of people will come in close proximity to me, and then I can self-declare myself as positive. Then all the people around will become positive, and that can create a chaos. So we just wanted this to be completely controlled, so that a social disturbance or a chaos did not come. And that is why the confirmation that a person is positive is sent done after a lot of cross-checking, and specifically done by a centralized system. And then there is also, this is where epidemiologist comes here. The epidemiological model is there, which basically analyzes once a particular mobile number, the owner of them tests positive, the data from that is extracted, and what will we get in the data? All the DIDs, please note, not the mobile numbers, but the DIDs that have come in close contact with them, the duration of the contact, and the time of duration of the contact, and the location. Now, there is an epidemiological model which was developed by epidemiologists, which actually looks at this contact trace information to classify each. Okay, A has become positive, B has come in some distance and spends this much amount of time in close proximity to A. So this model will classify whether he has a high risk or a moderate risk or a low risk. And this is intimated to the corresponding people that you had come in close contact to somebody who has now tested positive, and our model says that you have a high risk, please go and test, or a moderate risk, go and test. Low risk, please look at yourself. If there is any symptom, please go and do a test. And then this also send information back to the mobile of the trace DIDs on this classification, and that's what happens here. And then this cloud level also gives additional information to users, like the infection spread in the proximity, the nearby test centers, etc. And all these information that are given are aggregate information and no personalized information. Like we say that there are 100 people in the next 5 kilometers around you who are infected by COVID, but we don't say who is infected. And this is how the privacy and anonymization happens. Now, all these things, now we are collecting so much data, so we need to have a sort of some actionable items. For example, there are 200,000 self-assessments plus trace per day, and it's increasing. It is not possible for a single entity to follow up, and then they have to physically reach. Somebody says, I have fever, I have difficulty in breathing, I am immobile. No, we need to go and reach them. The system actually becomes useless without these follow-up actions. And that is where the location information becomes extremely important for us. Now, how we translated this to actionable item is very simple. Now, if you look at India, we have states. Within states, we have districts. We have districts. We have a lot of pin codes. And within pin codes, we have certain sub-post offices. So we have around 1,55,000 sub-post offices in the country. So for every sub-post office, there is a latitude and longitude, which is almost the center of the sub-post office. Now, now that we have the location information, we query the lat-lon and we find out the closest sub-post office for that lat-lon, and then we assign this task to that particular sub-post office. So this essentially leads to a good distribution of the work across the country, so that each person will see a limited number of things on which they need to attend to, and that person will be very in the closest proximity of that particular place. And so we actually developed a simple queryable structure. So what we did is we divided India into set of grids of 100 meter by 100 meter. So it will be several tens of thousands on your x-axis and tens in the y-axis. It's a multi-million matrix that we have, and so in which we fit this 1,55,000 pin codes, each as in one of these boxes in this grid. Basically, we used a hash structure. And then what we do is we do a simple search. So query point, let us say 1 is the query point. Then we search at that box to which it maps. Then the second one, mark 2. Then the 3, like just a wave. And then 4, etc. And within another 10 or 15 such squares, we would find the closest sub-post office. So at a sub-post office level, we were able to go and basically tell that this is the patient there, and he has called and he has certain problem. Go and reach them, call them, reach them. And this is the research process. And then the other part is this is about certain information. Somebody does a self-assessment, and when we go and reach them. But then there are other insights that we want to bring in, like this is statistics plays a very crucial role here. These are all aggregate information. No personal mobile information is provided. Wherein there was a syndromic mapping done by a very dedicated group at Indian Institute of Science, which using this data, using the self-assessment data, using the self-assessment data, and also using these using the trace data, for which we have this latitude and longitude, they did a syndromic mapping wherein we classified each of these grids as very high risk, moderate risk, and low risk. So at least 4 classifications. So that now at every sub-post office level, we have these grids, and these grids basically tell whether it's high risk, very high risk, moderate risk, and low risk. And so there could be concentrated surveillance of this disease spread at a small locations within the country. And so this was enabled, and this actually resulted in a very interesting protocol called Catch Early and Contain Early protocol, which was first conceived by the Ahmedabad Municipal Corporation, further adopted by multiple districts of Gujarat as of today. And many other states are also using this data. And note that this data carries only aggregate information and no personal information, and is available to the health workers. And this is what happened around. Times of India had been covering this very closely, following up. On May 27th, when the system was in full flesh, Ahmedabad decided to use this to pinpoint future hotspots. Hotspots in the sense those are having high incidence of this disease. And this is what happened on July 23rd, wherein, at the start of June, we had something like 600 cases. Around June second week, they started, June first weekend, they started this whole thing. By June 17th, the cases dropped to 330, and it dropped to 187 by July 17th, and today it is in that range of 150. And the number of the most important thing is the mortality. It was around 40 in around the second week of June, and it came to 22 within 2 weeks, and then it is currently at 3 to 5 for the last 1 month. And there were a lot of models that were projected on the mortality rate and infection, and the peak is achieved, and then there is a fall, and the fall is not that steep. It has been a smooth gradient, and that means a prolonged time for bringing it down. But then this fall in mortality rate was very steep because of this intervention, and that is how Aarogya Setu has helped. And this is one very important and a real case study that you can look at. The two real reasons behind this success: data is like a placard, right? So you go to a highway, it says that this place, say Pondicherry, is 160 kilometers from here, but the placard will not travel with you. You have to actually travel. So there are two real reasons behind success. This data just gave some pointers, but there was a dedicated team at Ahmedabad Municipal Corporation which worked round the clock, and people did submit the assessment and carried mobile phone with Bluetooth on. So there is a social responsibility that comes when we really want to contain this. And yes, there was a lot of responsibility given here, and these two are the real reasons behind success of this. And then comes the human aspects. Trust. First thing is the trust that the app is serving you and the country. That's so there were. The main thing is that there is a very clear sunset clause. It can be deleted at any time. Now, trust is a very interesting concept, right? When you try to define trust, define means you are trying to establish equivalence between the defined and the defined and the definition, right? So, and this equivalence, essentially, mathematically, it is, we have three important relationships: reflexive, symmetric, and transitive. Trust is not reflexive. You don't trust yourself as many times. Trust is not symmetric. A trust B, B may not trust A. A trust B, B trust C, A need not trust C, so it may not be transitive. And so trust is also temporal. Morning you trust, afternoon you don't trust. And there were concerns regarding privacy and data security. So we had made a lot of explanation of working, and privacy and data retention policies were made public. And government also opened up the code base for everyone to verify. And this is how we handle certain apprehensions about privacy, etc. From this point of view. And then, of course,
we have about 3 minutes here. Just a quick check.
Yeah, sure. So, we, from the background side, there was a lot of application development that had been done. Then performance testing, we used an IIT Madras open source tool for the same called Apido. This saves up to a couple of $1 million to do that level of massive testing. And we also did advanced penetration testing for protecting data, and of course data analytics. There's an open source stack again from IIT Madras. That's completely free thing that we have put together. People can look at datalibre.org.in for getting more details of this. And there's a very big pre-production performance assurance testing which was done. Stress, reliability, capacity planning, certain service level agreements, and transactions, key transactions, and performance tuning and regression test. All these things were taken up. And then on the assessment side, this is very important because there is going to be personalized data, and we have to be very careful. So we did application layer assessments and OS and architecture level assessments, and all these sort of heavy level security has been done. And code is also now open, and people can do this. There was a bug bounty that was also open. and for breaking certain things, if possible, so people can analyze and see if for the security for themselves. And this was the data analytics stack, and all this were open source, and we did not pay 1 rupee for that. And then this is how we developed the system, and a lot of indigenous efforts had gone in that. Thank you very much, and for questions.
Thank you, Kama. This is very, very relevant talk given around Aarogya Setu. We have a lot of questions around that. So we have 1 minute about so let's see. So one of the questions that is coming around is that if Bluetooth is not on, or given that Aarogya Setu works only on 2 dimension, and given that most urban India lives in multi-story houses, so how is it working? And so, do you have some view on it? Okay, how effective is in Indian context?
Yes. So if Bluetooth is on, if Bluetooth is not on, there is no use of this in contact tracing. Of course, self-assessment is also very important. Bluetooth is one part of contact tracing, but self-assessment is also very important to give us an incidence of the disease at a particular place. So self-assessment actually gives us much more detail about the presence of a disease in a very pointed location. So these two are important, and that is a massive social responsibility that you put these things on and it works. So if you don't do that, then it is ultimately this will not be the contact tracing cannot happen. But certainly we can keep the self-assessment data and do progress on it. Yes.
Let me ask one quick question on can you talk about the risk metrics and its validation, the high risk, moderate, and low risk? If there is any mathematical context of such scores, or if it includes any other hypothesis, quickly, if you could respond to that.
Yeah, so there is certainly a mathematics there. There has been a lot of statistics there. That high risk is something like, in our scoring it should be more than 1.5 or something. So I'm not going into the formulas of this because that we are not published it yet. But there is a strong statistical formula, and the statistics is also needed because there are a lot of times people actually say, I'm just testing the software. I just gave it this to test whether the software is working. And so there is some amount of noise that comes in. So there is a noise filtering that is happening, and on top of it, there is a statistical score that is evaluated based on this self-risk assessment and the number of patients who came from that particular area and the contact tracing. And based on that, a score is arrived, and that score has certain thresholds, and depending on those thresholds, we mark it as very high risk, moderate risk, and low risk.
Great, excellent. Thank you. We don't have any more time left, but if you have a few minutes, if you could respond, there are quite a few interesting questions on the panel. That would be great for the audience.
So, thank you. Thank you very much.
Thanks a lot, Kama. Thank a lot for your time. Thank you. Okay, over to you, Raj.
Yeah, thanks, Aarogya. So we will see you in the next session in a minute.